My name is Marley Wright and I am a research scientist at Agriculture Victoria. Our research has been investigating the use of real-time tools and technologies and management strategies that optimise nutrient intake in pasture-based dairy farm systems and increase average herd milk production from the existing feed base. We call it the Smart Feeding project. The Smart Feeding research uses sensor technologies combined with existing methodologies to develop a method for measuring dry matter intake in individual cows. This way we could record the animal's jaw movements for measuring the number of bite rates, rumination and grazing time, and low-cost gas sensors measuring the number of belches a cow makes, and microphones used for counting the number of swallows. Managers of dairy herds using pasture-based feeding systems face a unique set of challenges in providing optimal nutrition for their cows. Dairy cows managed in pasture-based systems can spend several hours away from pasture each day, walking to and from the dairy and waiting at the dairy to be milked. This can result in a marked disparity in pasture intake between cows within a herd, leading to differences in milk production. Understanding and being able to measure individual cow dry matter intake in near real time on commercial farms is critical to their goal of enabling herd managers to formulate and feed diets that are optimal for lactating cows. The findings of this research will offer dairy farmers strategies to optimise the nutrient intake of their herd, resulting in increased milk production without increasing total feed requirements. This research will, for the first time, enable individual cow dry matter intake to be estimated in pasture-based feeding systems. This in turn will allow for more accurate allocation of pasture and supplementary feed, resulting in more efficient and profitable allocation of on-farm feed resources. This research has identified the reduction in milk yield, 5 to 6 kilos per cow per day, from the first cow that enters a paddock to the last cow that enters a paddock after milking. This reduction in milk yield was due to a reduction in pasture quality and quantity across the grazing event, and this reduction occurred regardless of stage of lactation. The Smart Feeding project has also investigated strategies that mitigate the effect of milking order or prolonged time off pasture without increasing total feed requirements. Strategies that we have investigated so far include reserving fresh pasture for cows that arrive back to the paddock later in the grazing session, and reallocating the grain fed in the dairy by providing less grain to cows that are milked first and more grain to cows that are milked last. To date, we have seen some improvement to overall herd milk production when reserving fresh pasture for cows that arrive back to the paddock later in the grazing session in spring. Experiments conducted to date have allowed us to gather new data, compare and then validate different methods for dry matter intake estimation. This project will continue to develop these methods using data from our experiments, and we then plan to validate these methods on commercial farms. Prior to the completion of the Smart Feeding project, we will test the most successful strategy that mitigates the effect of prolonged time off pasture on 2 commercial farms. As commercial testing of our research strategies continues, we are able to advise farmers of the potential productivity and profitability benefits that they can implement on farm to mitigate the effects of milking order. If you are interested in finding out more about the Smart Feeding project or other feed-based research projects and how you can implement these within your business, I encourage you to visit the DairyFeedbase.com.au website.